Jain everyone. I am Shruti Jain, Assistant Professor, MC Department, Akgec Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is Relational Algebra. This topic is covered into Database Management System subject and the subject code is BMC 204. The target students for whom this topic is are the second semester students, first year MCA department. So let's understand what relational algebra is. Relation basically means when we are finding out any of the, when we are applying the algebra on any of the two tables, that is a relation. So a relation is basically a table on which we are finding out or on which we are putting some questions onto it. So relational algebra is a procedural query language. Procedural query language means when we have something to be solved in a procedural manner, like one step at a time, then followed by another step, followed by another step, that is a procedural query language. So relational algebra is procedural query language, whereas if we talk about SQL, SQL is a structured query language. As the name suggests, SQL structured query language. So relational algebra lays down the foundation for the queries, how it can be written or it can be structured into a query. So it consists of set of operations that take one or two relations as input and produce a new relation as their result. So it is a combination of multiple operations which when combined together gives you a result. There are 6 basic operations that we will be discussing today in today's lecture. We have the select operation, the project operation, union operation, set difference, Cartesian product and the rename operation. So let's take them one by one. Coming to the first operation, that is the select operation. The select operation works upon the tuples that are there in a relation. Now the tuples means the number of rows. Each row is a tuple when we are talking about the relation that is given over here. So the select operation, it selects the tuples that satisfy a given predicate. Predicate is the condition on the basis of which you need to identify the number of tuples or the number of records. So here we use the symbol as sigma, which tells us that we are going to select some of the things. Now the condition or the predicate that we are giving, that comes as a subscript of this sigma. So suppose if we look into the example over here, the example says that we have an instructor table and we need to identify all those records whose department name is physics. Now when we are to identify the records whose department name is physics, that means we need 3 things at a time. The first thing, the identification, whether we need the records to identify or we need the number of attributes to identify. So that is clear that we want the number of records to be identified. Number 2 is a condition or the predicate on which you want to on the basis of which you want to identify the records. And the most important thing is the relation on which you want to apply all those predicate things. So coming to the third part first, this is the instructor relation on which we need to identify the records. So instructor relation, because we need to identify the tuples, as we have seen in the first point over here, that we need to identify the number of tuples, that is why we'll use the select operator. Select operator is denoted by the sigma sign. Now the predicate value or the condition is that we need to identify all those records whose department name is physics. So we'll write down the condition that we'll select all those records with the department name physics. So we'll use the DPT name, that is the related attribute name, that is the DPT name, and in those DPT name we need to identify the physics subject. So this physics subject tells us that we are identifying all those records whose department name is physics from the relation instructor. So as soon as we get this, we'll get the records as this as a physics, this as a physics. So the two records will be identified. The first one is with the name Einstein and the other one is with the name Gold. So only these two records, this one and this one, will satisfy this predicate and will give you the result. So whatever condition, whatever predicate we want to give into this query always appears in the subscript. Now it is not necessary that this condition or the predicate is just a single one. It could be a combination of multiple attributes or multiple conditions. So in that case, we need to identify whether those conditions are joined by AND operator or the NOT operator. So we have the notations for AND, OR and NOT are the cap with upper cap with for OR and a dash kind of a thing for NOT. Suppose in this one only, we need to identify all those records where the department name is physics and the salary is, suppose the salary is 87.95. Salary is suppose 95,000. So the query in that case would be select. Now we have two things that are to be defined. So we'll write DPT name is equal to physics. Not only this, we also want all those records where the salary is 95,000 and we'll put the AND operator because we need both the things to be displayed, and we'll say AND salary is equal to 95,000. This is to be taken up from the instructor table. So the instructor would be the relation. Now in this case, we have two conditions to be satisfied. The first one is the same, that is given at the top, that is the department name is physics, and the other one is we need to identify all those records where the department name is physics along with the salary as 95,000. So in this case, we'll have the resultant query as this query, wherein we have the physics along with the salary as 95,000. So this is how we use this select operation. We have two examples written over here again, which identifies how the things are to be done. The first one is the table name is same that we were referring in the previous part. It says you need to identify all those instructors whose salary is greater than 65,000 as we have done just in the back one. In the previous one. So here we again need to identify all the records. So to identify all the records, we need the salary to be greater than 65,000. We'll write select where salary is greater than 65,000 from the instructor relation. That is simple, the way we have done in the previous one. Now let's see the next one. Select those instructors of the computer science department whose salary is greater than 75,000. So here we again have two conditions. The first one is we need to identify from the computer science department. Along with it, we need the salary to be greater than 75,000. So we'll select the department name as computer science and the salary greater than 75,000 from the instructor's relation. So, but if they say that we need to find those instructors who are there in the computer science department or they have a salary greater than 75,000. So when we use that OR part, either of the two can be true. In that case, we use OR over here. So it depends on the condition, how they are asking you, the type or the question they are asking you. On the basis of it, we identify the results. So if we talk about a relation, here again we have two conditions. The first condition that we have is on the attributes, that the column A, the attribute A and attribute B should be equal. Along with it, we need the value of the column D to be greater than 5. So if we have this relation R, the first condition that they are telling us is A should be equal to B. Now A equal to B comes under this. Here A is not equal to B. A equal to B comes under this, where we have alpha alpha and beta beta. Now the next condition that we need to identify to check is D greater than 5. So we'll be checking only in these records because we have already identified these records from the first condition. They say that D should be greater than 5. So if we check over here, this is D. D is greater than 5, 7 is greater than 5, true. Oh, sorry, we have this record as well for A equal to B. So we have 3 records, alpha alpha, beta beta, beta beta. Now D greater than 5, 7 holds true for D greater than 5. 3 does not satisfy this condition because 3 is not greater than 5. Then 10 also holds true because 10 is greater than 5. So ultimately we get this record and this record as the result. So the resultant would be alpha alpha 1 and 7, beta beta 23 and 10. So this is how we work on the the select operation. The next operation that we have is the project operation. The project operation is a unary operation which returns its argument relation with certain attributes left out. That means when in the previous one, we saw that whenever we are, in the previous one, we have seen that whatever records we are identifying, we are taking all the attributes in our solution. But if you want selected attributes where some of the attributes are left out and some are considered, in that case, we use a project operation. So the project operation is basically to identify the number of attributes wherein you are considering some of the attributes and leaving out some of the attributes that are not required. This projection operation is denoted by the symbol pi. So here all those attributes that we wish to appear in the result as a subscript to pi. Like in the select operation, we used the subscript for the conditions. Here we will write down the attribute names as the subscript to this pi. Let's take an example. Here one more thing that is required, that is the duplicate rows will be removed from the result. If we have 2 duplicate rows and we need to identify the result, in this case the duplicate rows will be removed. Now the example is we need to eliminate the department name attribute of the instructor table. Now because we need to eliminate this department name, we do not need this department name, but we need the rest of the attributes. In the project operation, we'll write ID, name and salary, ID, name and salary as a subscript to the project operation from the table instructor. So what it will do, it will remove this data and it will give us the rest of the relation as it is as a result of this operation. Let's take some of the examples. We need to find out the name and salary of all the instructors. We are not putting any of the condition. We just need the name and the salary of all the instructors. That means finding out the name and salary of all the instructors will tell us that we need the project operation on the name and the salary on the instructor table over here. So the resultant would be project from instructor table on the name and salary. Similarly, considering the next example, it says we need to find out the instructor ID and their respective departments. Again, we need 2 things. The instructor ID, this instructor ID is this one. Let me change the color so that it is clear to understand. So here we need the ID, the instructor ID, and also we need the respective department. So this is the respective department. Again, the 2 columns need to be identified. So we have the project operation on ID and department name from the instructor table. So this is clear that whenever we want to find out the records of from any of the relation, there we use a select operation. Whenever we need to identify the attributes from a given relation, we use the project operation. Now, there may be a possibility that we never want all the records with all the columns or selected columns with all the records. Like if we look into these questions, here we were identifying all the columns with certain records, and here we were identifying all the records with certain columns. It could be a possibility in normal scenarios that we need some conditions to be posed on some of the attributes. So in that case, what we'll do, we'll use the mixture of the select and the project operation. The select operation will identify the records that satisfy a particular condition. The project operation will identify the columns on which that select operation works. So let's take an example. The example says we need to find the name and ID of those instructors whose department name is physics. So there are two things. The first thing is, they are asking you to identify the name and ID, which are the attributes of the relation instructor. So because name and ID are the attributes of ID of the relation instructor, on these two we will be applying the project operation. Now, the next thing that they are saying, for only those instructors whose department name is physics. So this is a combination. We are applying the condition onto the records and we are finding out the selected columns. So only those records where the instructor name is physics. So the instructor name, the department name is physics. So the department name physics is these two. The result would be only these two things will be displayed as a result for this query. So when we are identifying the department name as physics, we'll write select department name as physics from the instructor table. It will first select how it works. It will first execute this part. This part will be executed first. So we get select from the instructor table on the basis of the predicate, the department name is physics. We'll get these two records as the answer. Now the next thing that they asked is the project operation on name and ID. So the result that we'll get will be only these two things. This one and this one. We'll get only 2222 with Einstein, and the other record would be 33456 with gold. So only these two things will be displayed, obviously with the heading ID and name. So we have a very important note that the project operation always applies on the column and the selection operation always applies on the rows. The next operation that we have is the union operation, which talks about finding out the combination of two or more things where we have the either or condition displayed. So here, let's take an example where it says find the names of all those bank customers who have either an account or loan or both. So when we are talking about this part, either an account or loan or both, that means we are using the union operation. Because union operation is to be applied on two of the things, that is why it is a binary operation. So to find out whether the person has an account, we'll find out the customer name with account. By C name would be some of the column or the attribute from the depositor table. So we got that column. Loan, the loan is taken from the borrower's table. Again, some column has been taken. Now, because we need either of the two, that is, it could satisfy both the conditions. So we'll use the union operation between these two project operations. Let's take an example. We have the relation R and S where we have this as R, this as S. When we do R union S, that means we have both the columns as same. R union S, alpha 1 will be displayed over here. Alpha 2 is common in these two, so only one will be displayed, that is alpha 2. Beta 1 is unique in both the relations. We will display beta 1. Now from this is already displayed. We will not consider this. Beta 3 is unique. So beta 3 will also be considered. The next operation that we have is the set difference operation. The set difference operation talks about where we want the data, we want to find out the records or the tuples from one relation that is not in the other relation. So, it is denoted by minus because it is a difference operation. It says to find the tuples that are in one relation but are not in the other. So, when we want to find out all those tuples that are in relation 1 but not in other, we use the set difference operation. Let's take an example. It says, you need to find out all those courses that were taught in the odd semester 2009 but not in odd semester 2010. So, that are there in 2009 but not in 2010, all those records or all those courses are to be displayed. Because we need to display only the courses, so we'll use the course IDs because it might be a possibility that this column would be having So here we have the section. What we need to identify, we need all those course IDs, all those courses that were there in the even semester that were there in the odd semester 2009 but not in odd semester 2010. That were there in odd semester 2009 but not in odd semester 2010. All those records are to be identified. So, where we have there is something in one relation but not in other, we use a set difference operation. We need to identify only the courses. So, we'll use a project operation on course ID. The condition, odd semester 2009. So, here what we are taking where the semester is equal to odd and the year is equal to 2009 for first one. That is, we need to select the semester equals to odd and year equals to 2009 as a result. The other condition is odd semester 2010. Again, the semester is odd, the year is 2010. We need both the things to be true. We again use AND with a set difference operation. So, this will give us this result. This result would be displayed. So, if we take it from the example, in the form of an example, we have two relations AB, R and S, and if we do R minus S, that means we need all those records that are there in the relation R but not in S, that are there in the relation R but not in S. Alpha 1 is there in R but not in S, so this will be displayed. Alpha 2 is there in R, it is also there in S, so we will not consider these. Next, beta 1 is there in R but not in S, so we will consider this. So, this is how the set difference operation works. The next operator that we have is Cartesian product. The Cartesian product allows us to combine the information from both the relations. Like if we talk about the set relation, the set difference was that is there in the first relation but not in other, but Cartesian product talks about that we are finding out the combination of both the relations, of all the relations. Suppose we have R and S. So, if we take this one, this alpha 1 would be connected with all the 4. So, we have alpha 1 connected with all the 4 as alpha 1, alpha 10A, beta 10A, beta 20B, gamma 10B. Similarly, this tuple will be related with all the tuples of the relation S and hence this would be the Cartesian result. The question is, we need to find out the names of all the customers who have loan at Pereridge branch. Having the loan at Pereridge branch is a condition. So, we'll use the branch name as Pereridge. Now, why do we need it as a Cartesian product? Let's take an example, the tables from here. We have two tables, the loan and borrower. The Pereridge branch is over here, but the branch, but how will we be able to identify we need all those records where the branch name, like if we look at the question, find the names of all those customers who have the loan at Perirage branch. So, finding out the customers, the name of the customers is in the table borrower. So, we need the combination, both the attributes together to be displayed. That is why we'll take the branch name as Perirage with the Cartesian product of the two, borrower into loan. Now, when we did borrower into loan, the problem that we faced was all the records of this were combined with all the records of this and got us this result only with the Perirage branch. That is, this was a Perirage branch, this was a Perirage branch, and all the records of this were combined with these two and we got all these records. Now the next thing, because we need to identify the Perirage branch wherein the loan numbers should be same. So here the loan numbers are not same in this case, but they are same in this, similarly in others. So in that case, we'll again use some condition wherein we'll say that the borrower loan number is equal to loan.loan number. Only those records are to be calculated or are to be taken up from this select where the borrower loan number is equal to the loan.loan number. So in that case, we get this as a result. So ultimately, because we need to identify the customer name, so we'll use a project operation with the customer name to get the result. So the the final result that we get is on this. The last operation that we have is the rename operation. Sometimes what happens, we need to do the Cartesian product on the same table. So to do it on the same table, we create an alias name, we rename that relation using this operator row. What it does, it creates an alias or it helps you to rename the relation E with the name X with certain attributes. Let's take an example. It says find the instructor salaries that are less than some other instructor salary. That means we are communicating with the same table in one condition. And we need to have the Cartesian product also, because when we have the two columns all together, we are able to compare the two. So what we'll do the Cartesian product of instructor table and we'll rename it with the name D by the rename operator row. Now when we do this, we need to do the instructor salaries that are there, that is less than with some other instructor. So we'll use a condition, instructor.salary should be less than D.salary. This is a condition on the select operation. We need to find out only the instructor salary. So we'll use the project operation on instructor.salary. So this is how the rename operation works. So that's all for today. In today's lecture, we have seen the different set operations, how these work upon. So coming to a brief of them, just a revision, quick revision. We talked about the 6 basic operators where the select operator works on the number of tuples. The project operator talks upon the attributes of the table. The union operator works upon is a binary operator that talks about that we need either from the first relation or from the other or both. Set difference is when we need some of the records from the first that are there in the first relation but not in the other. Cartesian product is a combination of all those records that are there in relation 1 and relation 2. When we need to rename a particular relation, we use the rename operator. That's all for today. Thank you.